Howdy everybody in YouTube land. What we have in front of us today is a Packard Bell Spectra. Now, I have never seen one of these in person. I've never worked on one of those. And I've never seen one of these back when they were in active use either. This is the very first one I've ever seen. Now, this one was dropped off to me for repair. I don't own this one. This is a customer's machine. Uh, it's in immaculate condition. And if we look at the sticker we have here, it is a 150 CD with an Intel 486DX2 processor and 420 meg drive, blah, blah, blah. So you can pause and read that if you wish. Now, the problem with this machine, the complaint is the monitor doesn't work. I don't know any further than that. And then I've got it plugged in. I haven't turned it on yet. We're going to find out here in a minute. And it looks like the way this thing is set up, it feels like a bodge. They've got the monitor looped out into the computer instead of using an internal harness. It's very, very odd. But without further ado, let's turn it on and verify the complaint. Okay, we have high voltage. That's good. Oh, I just heard it kick on. Do we have a picture? Yes, we do. But it's purple. So the monitor does work, but we are missing the green signal. Also, this has a 75, so someone's been in here and upgraded this thing. Okay, what tends to happen sometimes is if you look at this cable, you can see where it's pushed up against the wall all of its life. It's crinkled right here. So there's a strong possibility the only thing wrong here is that cable has got a bad connection. So let me flex on it a bit. No, it's not changing the behavior. Normally you would watch it pop in and out, but it's not changing the behavior. It's possible that it's broken. In any case, replacing that cable is less than fun, less than desirable. Because one, you would lose the originality because that's a nice purple, or not purple, wow, orange cable. You're not going to find that. What you're going to find now is either white or blue. But the other problem is I'd have to sneak it inside, cut it, and then solder it into the existing harness. And that is not going to be fun either way I look at it. So I need to take this thing apart and verify that that is indeed the case. It's that it's broken to the neck board. The other thing I want to do is I want to inspect the analog board, the neck board for bad solder joints, stuff like that. And moreover, we need to take a look at this machine, especially this drive, considering this is about a 1993-94 machine thereabouts. These tend to have leaky capacitors in it. So I need to inspect the power supply, I need to inspect the drives, and all of that stuff for bad capacitors. So without further ado, let's get this thing apart, because I want to do a tear down and see what we got going on inside here, because I've never seen one of these and this thing's cool. Oh yeah, one more note before I take this apart. I want to point one thing out. It's purple. It's missing the green signal. I have a suspicion it may not be the cable, and here's why. When I turn this off, it flashes on the screen purple as well. It doesn't turn white like you would see when a raster collapses. That has my alarm bells ringing. But here's what I find hilarious. We've got an edge connector down there for power. So, would it have killed them to run the video through the edge connector? Anywho. So we've got our 5, 12, all of that. Positive 5. It's just all general. 1994, 45th week. So this machine was probably released in 1995. So let's see, serial number 94. So this machine was probably sold in 95, if I were to guess. Now, we'll look into this more detail later, but this is the motherboard assembly. Well, we don't have to worry about the 24 megabytes because that's a 24 nothing at this point. It's been pulled. And the CD-ROM drive is May 1995. So this was a 1995 machine. Original audio modem hardware. And looks like an Intel Overdrive CPU. Or no cache memory. Cirrus Logic. So we'll explore this in detail later. I want to get that monitor apart. This is the christening. I'm about to be the first person that's ever been in this monitor, because guess what's behind this sticker? The screw. Risk of electric shock. Do not open. Well, too late, because I just ruptured that sticker. So all 4 screws are out. I'm going to be the first, since its manufacture, that this monitor has ever been apart. Now I gotta figure out how to get it off. I need both hands. Behind door number A, this is what we have. So let's take a look at some labels here. There's our model number of the chassis, model number, whatever you want to call it, made in Taiwan. I'm not sure who actually made this monitor yet. We're gonna find out. Little tiny itty bitty speakers. It's not super high hour, but it's also not low hour. This machine probably got 3-4 years of use and was upgraded, because otherwise it would have a lot more soot. And then there's the shield. Now, this shield's going to have to come off, and it's going to be an interesting, fun experience to remove that, but these combos always are. So, there's our main power supply board. Nothing out of the ordinary there. And then there's our analog monitor board, flyback transformer, and our cable. So the quickest thing I can do is check this cable and make sure it's buzzing back to this board. But I have a suspicion that that is not our problem. Yeah, I'm going to have to pull this thing even further apart. I have to remove this support bracket and remove this neck board. Remove the screws there. This is going up to the DAG ground. Yep. I got to figure out where that goes, because I have to take all these grounds off and get this neck board out so I can get a closer inspection of what is going on here. Flipping it over to the top reveals something that I really did not want to see. That right here. See that? That's the plastic shrinking and cracking on the flyback transformer. Ugh. Well, there's the part number of the flyback right there. That is not good. It's gonna fail before long. Alright, after removing this globtacular silicone stuff, looking at the board, this should not be too difficult to repair as long as it's not a picture tube problem, because we just have our average Jelly Bean run-of-the-mill LM1203 video amplifier, and we have our 3 color output transistors, and one of them is green. So the first thing I want to do is I want to unplug the VGA cable, and we're going to test to make sure the VGA cable is conducting through there. Because if not, well, that's our whole problem, and we're going to have to make a new one somehow. Don't ask me how yet. But if everything is good there, then we have to look deeper into the circuitry. I did a quick check. All 3 colors are buzzing out. So I am getting green from the cable up to the board, and you can test them right there at those 3 inductor ferrite beads easier than you can jabbing a probe in there. But so that means our problem is somewhere on this board, or we have an open cathode in the CRT, which I highly doubt, because when it collapsed to a vertical line this way, I saw a little bit of white. So I don't think we have an open cathode. It might be, but I strongly doubt it. I think our issue is going to be on this board. So that means we need to get this board removed, which is easier said than done, because instead of using JST connectors, they soldered it to the board there. And if you follow it through, it's also soldered to the board up here. So I can't remove this board independently. that means I'm going to have to work with it as it is, which is going to be really fun. Really, really fun. Those of you who are playing at home, the CRT is a Changwa. EIA code 577, and I don't know if you can see in there, but the part number is down in there like so. Ground strap being in the way does definitely not help. We'll figure it out. But anywho, that's the picture tube. Alright, well, at first glance, I'm not really seeing anything out of the ordinary here, with the exception of one thing. And if we zoom in really carefully here, perhaps you can see it. A short between pins 10 and 9, or something that, some kind of debris. So, yeah, that needs to get cleaned out of there, but other than that, I'm not seeing anything standing out at me. And I went ahead and did a diode check of this transistor and these two, because this is the green circuit, and it's fine. So whatever's going on here is going to be an electrical gremlin. Alright, so let me get a test set up going here. I'm going to get my scope turned on. But a very generous person has given me this thing. And this is my first time using it, so I don't know if it's going to work. So let me kick this thing on. Okay. Do we have anything at all? Oh yeah, there we go. Okay, so, ooh, we got all kinds of things going. We got some distortions up here. Wow. This is the pattern. Blue. Ooh. There's something wrong there. Oh, this thing's got all kinds of fun things. We got red. Blue, blue's not really, I don't know, there's something wrong here. Blue is not working right. If there's too much blue signal, it just kind of goes dead. Yeah, we've got issues. That is for sure. I'm starting to suspect we have capacitor problems on the neck board. Because look at this. Yeah, this isn't... That button's bad too. Red. Yeah, that's supposed to be green. That's blue. And blue is not really... something's wrong here. Yeah. If the blue signal is low, I don't have a problem. But if I switch over to green, I got nothing, of course. And then red is... Yeah, this... Something's wrong here. The fun thing is I'm able to drive this thing all the way up to 1024 by 768. That's impressive. But we've definitely, just by looking at this, we have capacitor issues. I mean, blue's trying to come in, but not really. It's supposed to be red, blue, and then green over here, maybe? I don't know. I've never used this pattern generator before, but yeah, we got it there. Yeah, just kind of there, but... Oh, it showed up for a second and went away. But you can see where our issues are. So we've definitely got problems. We got problems in the video amplifier, video output section. And if I were to guess, it's probably bad electrolytic capacitors. Could be wrong. It could be a bad LM1203, but if I were to guess, it's bad electrolytic capacitors. And the way I'm going to determine that is I'm going to heat this board up with a heat gun and see if the picture comes back. So let me get this pattern generator set up. I'm going to switch this back to a safer 640 by 480, and we're going to get this thing lit up with the, the bar pattern and see if things improve as I heat this board up. This is where things get fun. So let me kick this on right now. Alright, and then we're going to kick the monitor on. I got to switch hands here, because I'm going to hold this one to the screen, and I'm going to grab my heat gun, and we're going to heat this thing up. So, do we have output? And whoops, hang on, we got to switch over here. Yeah, we do. Kind of, sort of. So, I'm going to heat this thing up. And let's see what happens. Heat the back of the board like this. And see if the picture quality improves. I don't know if it will. But only one way to find out. Try not to get close to this anode lead. Be very careful. Not really. Although the blue tinging is going down. Let me heat the analog board up. Could be an open capacitor. That's entirely possible. Or it could be the LM1203. It could also be back. I've run into weird instances like that. Alright, well, using the heat gun has made no difference. Actually, yeah, the blue is coming back. See that? It is. The blue is coming back. Let me heat this board up some more. Yeah, the blue is coming back. Well, how about that? Trying to be careful because I don't want to overheat it to the point where things burn. Or I crack the tube. But look at that. It's coming back. Strongly. Just heating up the capacitors on the board. Or heating up the board anyways. See? That's all I'm doing. We got perfect blue now. Question is, do we get green back? Or is green too far gone? But this is very much a troubleshooting technique. Well, blue came back. So, oh, there we go. Look at this. Look at this. Look at that. Green has come back. Nice. So, what do we have wrong here? We have bad capacitors on the neck board. The other thing I wanted to point out too, the brand of capacitors on that board are Capixon and Elite and a few other ones, which, but once I got it hot, look at that. It snapped right in. Now that we got full color, I want to see how this tester works real quick. So we have full convergence, dots, full whatever that is, white, red, green, blue, red convergence, red dots, red whatever, green, 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 blue, 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 and then full color bars, and then we're back to convergence. So yes, there we go. Now, I want to see though, let's see what 800 by 600 looks like. Let's turn 800 by 600 on. So 800 by 600 works. And then let's try 1024 by 768. Yeah, yeah, it works. So I'm impressed. All right. Good enough. So we have a neck board problem. So that's what we got going on, is the neck board. Let's make sure this power is off. I'm pretty sure it is. And if not, it is now. All right. So, where do we go from here? Well, we got to work on this neck board. This neck board is nice and hot now. It's very, very hot. Yeah, so that's our issue. I'm going to let this cool down, and we're going to turn it on again, and we're going to verify that the problem has come back. All right, so now that we know what the problem is, what we're going to do for one last time is, it's been cooling off for a little bit of time, like an hour or so. So we're going to turn this guy back on. Switch you to 640 by 480. It already is. And we're going to turn you on. And see if we have the same fault. It should have returned. No, it hasn't. I'm impressed. Why is it now that it's been off for an hour, it comes on and works perfect? Okay. Temporarily reformed the capacitors? I don't know. I don't know about that. Anywho, so I've gotten the go-ahead to just go ahead and recap this thing. Can we just replace the few on the neck board and get it going? Yeah, we probably could. But this thing is 30 years old. Let's just put it out there right now. This thing's 30 years old. So what I'm going to do is we're going to pull this thing apart and we're going to do a capacitor list of all of these boards. And then we're going to replace them. We're going to recap this thing and try it again. But I did find it interesting. It's cooled completely down. It's been sitting for over an hour and it came back up perfect. I don't know about that. You know, sometimes I really hate all-in-one machines. Trying to get all of this out of here is proving to be a very painful experience. Pulling these boards. 0 out of 10. Don't recommend. You know things are going to be going amazingly well when you see these Elna RSG Long Life series. These things get absolutely nasty. This one hasn't, but it will, because they all do. Alright, so I got my paper out. We're going to go ahead and get the capacitor list together on all of this stuff. And I'll just put it in the video so people can have that as a reference. If they have one of these machines, don't see many of these in the wild, so who knows. Anyways, one thing I noticed right away is the Elna Long Life capacitors. These things are a big problem with the earlier stuff, so I don't see them leaking on this board, probably because they're a year or two newer than the ones I see leaking, but they are a known problem, so we've got to get all of these changed out. Not to mention we've got, you know, this crappy capacitor plague brand, which this was before the cat plague, but again, needs to go away. 1995 era hardware, and we've already seen that we had trouble with the capacitors over here that somehow reformed, I want to say, but anyways, they all need to come off and they all need to be replaced. One thing I will absolutely point out, though, is it seems like when they manufactured this device, they scrounged up capacitors wherever they can get them, because I've seen 1 microfarad 50 volt caps in here that are from TPO. Then there's one over there from like Elite, and they're just all different brands, but they're a lot of the same values. I don't get it, because on this board you have, you know, Emron or whatever brand that is. I can't read it. And then right next to that, same exact value, that's an Elna. And they're all the same values. And then we have Capixon or Crapixon over there. And if you pronounce it in a Chinese way, it's Caption. So you have that. And then you have a TPO over there. So, oh, what a mess. Anywho, I have all of the capacitors logged now. So there's the power supply board. Everything marked in E are low ESR capacitors based on my own experience. I haven't looked up the series, but just what I know about switching power supply design, that's what they're going to be. So there's all of those. These are the big snap-ins down there. And then on the other side, we have the analog board. So that there is all the caps for that. That's this board here. And then the neck board, which is the one I'm pretty sure we were having the problems on, are all of these. Now, the problem is I've got most of these caps, The only ones I'm probably not going to have are these high voltage ones like the 250s and the 160s. And I've got some of those on hand, but not all of them. And some of the ones I have on hand I got for like color classics and stuff like that. Like this is a common value used in the color classic and all of those. So I may have those, but I know I'm not going to have that one. I think I only have those in 200 volts. And then there's a 4.7 at 250. I know I don't have that one. And I thought there was one at 400 volt, but I could be wrong. That might be on this one over here. So there's a 220 at 160. There it is, one at 450. I may or may not have that one. I'll have to look and see. But yes, there's our caps. And at this point, it's time to start getting them checked out and ordered and replacing them. I went ahead and ordered all of the capacitors of the high voltage ones that I was missing. So I should have our 250 volt caps and all of this stuff because I was lacking those. Because high voltage caps are not something I really keep on hand. But good news is they're now in here, so I can finally start to get those two boards recapped. I got all the caps together. I don't know if I have all of them, but I just started pulling them out of my bin and throwing them up here. I got to figure out an organization system that works for these. Anyway, so I'm starting up here in the corner, unsoldered this one, and look at what we got going on here. Perhaps I can see this better in the light. Look at this. Yeah, see that? We've already got... Let's pull this out of the silicone. Oh, yeah. Yeah. Crapixon for you. So this was made when? 1995. So there you go. Your Packard Bell Spectra needs recapped. Alright, so I got all the caps stripped off of it. And the only ones worthy to note, I want to test these because I generally don't buy these. So I want to test those and make sure they're good. And then if they are, I'm going to shove them back in here. But the only ones worthy to note are the low ESR ones, like these 3300 at 10 volt Capixon. Not all of these were leaking, but a grand majority of them were. Like this one definitely was. And then these elite ones, which are 220 at 160, were also getting kind of crusty. You can see it right there. So all of these, that one too, yeah, they're problematic. So these are probably dried out, and that will certainly cause a lot of what we were seeing. So anyways, we've got to change all of those out, and I should have most of them there. Once I get those in here, I'm going to resolder all of the hot spots on this board and see where we go from there. That's a very interesting bodge. Anyway, so that is it for that. I need to make sure I didn't miss any. I don't think that I did, but you can never be too sure. But I think we're all right. I think we got them all. Nothing crazy. All right. That's what we're going to do. Well, I'm going to start off by putting these back in here. But before I do, I want to go ahead and test them. So I bought these little LCR tweezers. I thought I saw someone else using these things, and they're kind of cool, and I can use these single-handedly, which makes life a lot easier. 625? What are these? 680. So they're reading a little low. So they've dried out a tiny bit over the years. Reading about the same. So I think we're all right. I'm just going to shove those back in there, and then we'll move on. Just for grins and shiggles, let's read this 220 at 160, because I have my concerns. Well, it's actually reading. So, I mean, I don't know. Obviously, they're not exactly great to use when they're showing signs of leakage, but you never know. you could get by. Anyways, moving right along. Alright, all the new caps are installed with the exception of these two. I tested those, they're fine, so I put them back in there. All of the other ones have been changed, though. I could go through them later to see how many of them are bad, besides the leaking ones. And that is going to do it with this particular board. So power supply is taken care of. Lastly, I have to do the analog board and the CRT neck board. And if I run into anything, I will pick the camera back up. Otherwise, I will continue to move on. Alright, so there's another reason why we need to get rid of these caps. Because look, new fear unlocked. So this is an elite brand, but no, this is that stupid caption, Capexon, Crapexon, whatever. You see how that looks oily? It's not really leaking. However, if we zoom in and I do this, watch this. I can literally take this rubber seal and put it's gone sticky. So the rubber has molten. Oh wow, that's not good. That is actually really bad. So all of these caps have to go. And there we go. That board now has all of its capacitors installed. All the old ones are out. They're in various states of disrepair. We've got some with molten rubbered plugs. We got some that are just dried out and completely out of tolerance. And it's the ones that was on this board, which is no surprise considering what our symptoms were. And that kind of thing. But they're all in there now. Some new ones are in there. We got all these little Worth caps, which I kind of like the look of those. They look so pretty. But anywho, they're all in there now. So I think at this point, it's time to start slowly getting this thing back there. Actually, before I do that, I do want to test the picture tube to make sure. Yeah, everything's labeled here. So I do want to measure the picture tube just to see what kind of condition it's in, because I am curious. Alright, so we are wired up to the blue cathode here, so now I gotta adjust the filament. Alright, bring this up to 6.3 volt, which is I think where it needs to be. Yep, we got filament glow. Check shorts, no shorts. Set gun balance. Got plenty of cutoff. So we're going to set our gun balance to there. And then emission. Wow. So our emission is pretty close to 14. Yeah, pretty close to 14, like 13.8. So that's where our emission is there. All right. So now we're going to take our gun balance. We're going to move it from blue to red, which is on the other side of the heater here. All right. That's pretty even. Oh yeah, the blue is stronger. Or no. That's green. The green. No. I'm getting this mixed up. Blue. It goes blue, red, green. Blue, red, green. Blue was good. Red is a little bit stronger, but about the same. So we're going to set you there. Now we're going to check green, which is right here. It's going to be fun to get to. There's green. All right. Cutoff's good. Emissions are the same. So let's check the life test. Life test is solid. Good enough. Let the cap discharge in my tester. We're good. All right. So the picture tube is actually pretty strong. So this tube has a lot of life left in it anyways. So really what got to this thing was just age. You know, caps just went bad with age. All right. So, I got to get this thing put back together. Yeah, fun. But that's who made the tube, if anyone's curious. All right, with that out of the way, we need to start putting this thing back together. And let me tell you, this is no small feat, just how it's designed, because this monitor was actually a separate monitor. What they did was they took the bottom half off and they bolted it to the metal frame. It's a very hacky setup. And you could tell just by how the VGA cable was looped out. So this monitor, it's just weird. But I will say one cool thing about this thing, though, is it uses the AT power connector standard. So there is that. Putting this together is tricky because you have to assemble this thing as the monitor itself. Otherwise, you're not going to be able to get to all the cables. It's just not possible. And that's the way I took it apart, and it just was so weird. So instead, what I did was I put the monitor together. That way I can get on both sides. And then with the monitor together, I could plug these cables in down here with it pivoted like this. So then the thought process behind this is this will come together like a sandwich. And then since this is in the rear, it'll be far easier to just get that plugged in, since all I got to do is just go boink, plug it in right there as well as here. So, at least that's the current line of thinking. We'll see. Recapicides can be dangerous because you never know how it's going to go. Especially something this complex, it's really easy to make a mistake. I could put a cap in here backwards, anything's possible. So, without further ado, if anything is wrong, we're going to get it on camera. So, here we go. Alright, let's turn it on. Where's our switch? Well, it turned on and powered off. Which might be normal, might not be. Okay. Well, let me grab my generator tool here, which is right here. I love this little tool. Plug you in. Zoom out. Turn you on. Okay, it is on. Do we have a picture? No, we do not. Do we have any? Nope. I think it's going into shutdown. So we have other issues. Well then. Yep, it's coming on and going into shutdown. So we, unfortunately, have made a mistake. Which sucks because what mistake did we make? Did we put the wrong value capacitor in there? It's possible. The trouble with that is, since all the original ones are not in there anymore, it's hard to tell which one it is. So, unfortunately, yeah, that's fun. So let me go through this and make sure I didn't make any other weird mistakes, but it does not seem to work. Well, if we look carefully down here, I see that wiggly. I forgot to solder a solder connection. Whoops. All right, well, let me fix that real quick. All right, well, with that soldered, or resoldered, I checked for other ones. Didn't miss any. Maybe in the power supply section. No, I don't see anything. So let's hope that... Hopefully that's all it was. Because it was going into shutdown. So let's see. Nope. Still going into shutdown. Well, let's find out if it stays on with our signal like before. So here we go. We're going to plug our signal in here. Turn it on. And here we go. Let's try again. Nope. Still shutting down. Still going into shutdown. Knew it couldn't be that easy. Darn. Yeah, I've got all the plugs in the right spots that I can see. Yeah, that's weird. Such a weird failure. I was hoping it was going to be something simple, but unfortunately not. All right, well, taking a closer look at the board, I forgot C203. At first I thought it was unpopulated, but if we take a look down here, you can kind of see there was, yeah, there it is. There was a cap soldered there at one time. So, that's two mistakes I've made on this board. Crap. So what value is that? It is 2.2 at 50. Oops. Well, there's one I forgot. Oh, that's right. I remember what happened now. I ran out of 2.2 at 50 caps and I totally forgot. So I didn't even pay attention. Closest I can get was a couple 1 microfarads in parallel. Hopefully that's close enough. We're going to find out. But it is on my to order list. So crap. Oh well, is what it is. It's getting late. I'm going to go catch some shut-eye, and then we'll pick this back up in the morning. Alright. I want to see if I can't get this thing to power up in its state like this, because I don't want to put this thing all the way back together and it not work and have to take it all the way back apart. So, let's see. Turn it on. High voltage. And then shut down. Alright, well, I don't know. I'm not holding high hopes. So, here's the issue. Because I have it sitting down like this, it's going to be hard. Let's see here. Let me get this thing. Of course, it's upside down. So that makes things fun. And then I got to re-solder that back down, but whatever. Alright, turn it back on. Let's turn this on. Oh, hey, high voltage came up. Do we have picture? Yeah, we do. We do. We have a picture. Alright. That's good. Shut you down. And then get this thing re-energized, or get this thing put back up into the thing. That's good. We have a picture. So I got to get this wire stripped and get it, soldered back on here, because you've got to cut that wire in order to get all of this off. And in a perfect world, I don't know why they did it this way. They could have put a ring terminal on it and put it right here, but whatever. All right, so here we go again. Let's turn it on. We're powered up. Let's turn our video pattern generator on. This should be 640 by 480 by 60. And there we go. Wow. That's actually much clearer than what I had before. I mean, it was pretty sharp before, but now it's really good. Wow. There. My two mistakes are fixed. Forgot to solder the one cap, and I didn't put the other one in because I ran out and forgot that I ran out, because this has spanned almost a month long, this whole project. So, yeah, things like that tend to happen. But hey, we've got a nice picture now. So good. Power supply's running. TV's running, monitor's running. The only thing I got to do now is pay attention to caps and make sure none of them explode on me because I have them installed backwards. That's always a possibility. But, yes. Okay. We're good. Got to get the computer put back in here. All right. One last thing before I get the thing put back together. Right here. See this? How it gets a little purple? before it gets white. So what this actually is we've got our biases and our drives back here. So since we've changed the capacitors, including the coupling capacitors, into the 1203, we have to physically adjust these bias and gain controls to get them matched. So we have to do this at the low end. As we can see, it's got too much red, not enough green. And then we got to do this at the high end where we've got too much blue and not enough green. So we've got to adjust the green and all of that because this is a white screen. So that's what we're going to do next, is adjust our black levels, which on this monitor I think is the cutoffs, and then the drives are where we at the top end. So just like a TV, you know, same type of situation. It's about as good as it's gonna get. It ain't no Trinitron, I'll tell you that. But hey, it's working. There is some non-linearities when it comes to the brightness range, but you can see it hit the beam current limiter right there, see? But you got to bring the, yeah, it's, and the tube is strong. It's just not a very good monitor. But anyways, it's working fine, so I'm going to go ahead and get the computer put back in here. All right, with the monitor out of the way, now we need to deal with the computer side of things. So, hard drive's missing, unfortunately, but I'll throw something in there. Not a big deal. I got plenty of miscellaneous drives I can use for that. So I'll throw a drive in there, and then we've got to get this thing stripped down because we have to check everything inside here to make sure there's no other issues. But more importantly, we've got to get to these things in there. So not only do we have to get to the floppy drive, we also have to get to the CD-ROM drive, because this is the exact same type of drive that I've seen in the Macs, and we all know what happens to those. So I got to strip this guy down, and we've got to start checking all of the parts inside here for quality issues. Wow, that got Quarko-twinkulated quite a bit. Whoops. So I'm trying to figure out how to get into this thing, and so far I found a screw there, 2 screws here, 1 and 2, and then a screw right here, and it looks like someone's yanking on this before trying to figure out how to take it apart, because this thing's all twerked. But also typical Packard Bell and their audio modem combo cards. I remember these things. So we've got a Crystal Audio 4231, which I don't know if it has DOS sound support. Probably not. That's probably Windows only. We've got our Yamaha OPL chip and all of this other fun stuff, and some random metal can transistor. Anyways, we got you out of the way. That leaves the board itself, which is going to be fun. There's no cache memory, I see, for the video hardware, so it's going to have not so great performance in the video department. Okay, how do I thingamabob? I think this, yeah, this is fun. So I've got to get you out. Why did they design it in such an odd way? So odd. Has this got a 2032 anywhere in here, or is this one of those Dallas Wonder Muffins? We're going to get to that too. Okay, time to continue digging into this thing, but we've got a DX475. That's a cool chip. Someone definitely mangled the crap out of this thing to get the hard drive out, because wow, this is all bent up, out of shape. I don't know if I can straighten that out or not, maybe. And then of course this just fell off the floppy drive because it is broken. So oh boy. Okay, so this just slid out of the board. It was fairly easy. But I'm going to get this big mess of cables out of here and get these drives out of here. And yeah, fun. Yeah. Mangled much? Looking at the motherboard, it's pretty bare bones. So we've got no tag memory, we've got no cache memory, we've got no video expansion, so pretty bare bones. Not going to be a good performer without all of that. unless this chip has something on board or on chip. I don't know. Not likely. Secondarily, we've got a soldered on battery here, so we're gonna have to take care of that, because I don't think that's rechargeable. Yeah, it might be, but I guarantee it's dead. So easy thing to do would be remove that and just put a diode in series and use a CR2032. More importantly, we got to pay attention to the electrolytics, because sure enough, we have the same exact Capexon garbage there, which has the molten rubber plug syndrome. So those are going to have to be replaced as well. So we've got our work cut out ahead of us. So we have, let's see, we've got you here, we've got an orange and white, and then black, blue, red on the front panel. And I doubt there's going to be any information on this, so we got to take a note of where that is. Same thing here. And this is our interface card. So we've got speaker in goes here. So we're going to remove you. The other one goes up here, which is probably headphones. I'm not going to worry about that. Yeah, so we got to get all this crap out of here. So both of these boards, front panel boards, have those stupid Capexon caps with the molten rubber plug. So it's funny because this was the brand that was known for the plague, right? Well, this was pre-plague. It just has age-related problems. So we got to do that. Now the motherboard itself, nothing out of the ordinary there, but it has a bunch of electrolytics on it also. However, these are the better Panasonic brands, so I'm going to leave those alone. The likelihood of needing those is very minute, but I'm going to leave those alone. So we're going to set the motherboard aside for now. We'll get to the battery last. The more important thing for me is getting all these caps off and replaced, as well as getting into these drives and seeing what we got going on in there as far as caps and all of that is too. So we're just going to get all of that out of the way. So this drive does not use surface mount caps, so it's probably all right. However, it's degrading in other ways. Well, obviously we have our eject belt that's bad, but more importantly, we have this degrading spindle plate with this rubber coating on it, and it's really starting to get bad. So, they're starting to go bad in other ways. I'm going to do the best I can with it. I'm going to take it apart and check everything and then put it back together. Alright, so these are all Panasonic caps and none are leaking. So I am going to leave them alone. These belts are a bit hard to find because they're smaller, and all those belt kits that I buy are always large. So I'm going to go ahead and try to boil this and see if I can't restore that, and then try to clean up the laser and the spindle. Not holding high hopes, but we're going to try. So this drive only has the one capacitor, so I just went ahead and replaced it. It's not showing any signs of leaking or anything like that, but I know these particular ones like to leak in the PowerBook drive, so I just went ahead and changed it. I'm not going to touch those. I'm going to just go ahead and clean things up, re-grease it, and reassemble it, and see where we go with it. Alright, drive is powered up. I got the belt in there. Let's see what happens. Oh, this is hard to do single-handedly. So I'm going to use a CDR. I'm just curious if it'll read it. It's trying. Yep, picked it up. This thing actually might work. That's a good thing, because we're going to need it to install, you know, Windows and DOS and all that stuff on the machine. Yeah, we got a laser, even though you can't really see it. Yeah, it's fine. Although the sound of the stepper sled's not that great. I'm wondering if there's a small crack in the gear. And if there is, there's not much I can do about it. But the drive seems to be alive. Alright, well, a quick Google search has revealed that this BR1225 battery is a non-rechargeable battery. So once it's dead, it's dead. So I felt safe enough to wire this 2032 holder in there, and I'll just find a spot in the chassis to anchor it. And that should be good. We'll be able to set our CMOS settings and be good from there. I don't know what kind of RAM we have. I might need to, like, you know, put some more in there just so I can run Windows properly, but we'll see. We'll see how it is. So I think I'm at the point now where I can start reassembling this thing. Besides, I got to take the drive cage and pound down the metal a little bit, see if I can't flatten it. I don't know. I'm not expecting miracles there either. This thing was kind of hard to put back together, so let's hope this thing works. I gave it the curse. Put a Maxtor hard drive in it. Now that one spins up and passes a seek test. Don't know if it's good, but we're going to find out. Getting this whole tray in and out and the cables snaked in here is not fun. But it's done, so let's see what we get going on now. All right, so the board's back in there. Let's see what happens. Well, couple things. It turned on, but no post. Probably doesn't like the RAM I put in there. Floppy drive is stuck on, as usual. We got a power LED, so that's good. Does this work? Yeah, we've got no post. Darn it. Alright, well, we gotta take it back apart. Try again. Alright, let's try again. Still have a problem over here with that. Okay. Whoa, yeah, that's bright. Alright. Yeah, we still have some non-linearities in the, yeah. If you turn the brightness all the way up, we lose. Back you down quite a bit. Ooh, yeah. So you can see we've got some non-linearities going on here, and I don't know why that is. It's not capacitor related. Needs to be right there. That's where we are with it. That's where it needs to be. Alright, so let's get in here and adjust the G2 drive a tiny bit. Okay. Perhaps it was just a bit too strong. Might have got bumped. Yeah, I don't like that. Yeah, so, yeah. This is good, right about where it is. That's fine. So, we got a problem with the floppy drive. I tried flipping the cable around, and it's still a problem, so I have to get that fixed, or it's not going to boot. Not sure what's going on with that, so we got to pull this thing back apart and check it again. Alright, here we go again. Let's flip the floppy cable around on the motherboard. Oh, no more green light. There we go. We're good. So we have 8 megabytes of RAM, which is a little light in my opinion, but it's not liking my RAM stick. I don't like the non-linearities of this thing that well. You know, I'm starting to suspect... Yeah, you know what I'm starting to suspect? I'm probably not going to feel good until I replace it, but I'm starting to suspect that LM1203 on the neck board is bad, and here's why. Because when we first got this thing, to you it's been a matter of minutes in a video, but to me it's been weeks. It had a really weird picture. And then I heated everything up and it snapped in and came back. But I noticed once I let it cool down, the fault didn't return. So I said, okay, well, it's time to recap it because there were some caps that were going bad. And then the caps on the neck board were out of tolerance. So replacing the caps, it's working all right, but there's still that weird non-linearity in the color. And the only thing responsible for that is that 1203 and those 3 cathode driver transistors there. So those are your video drivers, and then your video amplifier is in that LM1203. So I'm starting to suspect that 1203 has gone bad. So the only way I know forward from here is probably just to order one. I don't think I have one, so I'm probably just going to order one, throw it in there, and see if it changes how this behaves. But in the meantime, I'm going to go ahead and try to get this system up and going to some way, in some degree anyways. Oh yeah, look at this. That is not good. No. That is bad. I'm sorry, but that's bad. That's a 1203 failure right there. It's not caps. Yeah, it's not caps. That's a bad 1203. Not good. Not good at all. All right, well, so much for that, but we're just going to have to deal with it. I'm currently wiping the drive right now, but I am having a problem. It's not detecting the CD-ROM drive, even though when this driver tries to load, I see this yellow light come on. So clearly the IDE bus and the CD-ROM is getting a signal, but I don't know, maybe these drives need a special driver. Not entirely certain on that one. You know, the Oak CD-ROM.sys driver is one of the most universal drivers there are for DOS CD-ROM drivers, except in this case. I had to switch drivers to the CR, what is it, cratappy.sys for this drive. And now, there it is. Now it's working. So, yeah. How about that? Yeah, this is actually getting worse the longer it runs. So I've got the 1203 chips on order, so hopefully that solves our problem. But in the meantime, I need to get this done. So here we go. Now Windows 95 is being copied over right now. Now that CD-ROM drive is kind of working, but it's kind of iffy. Basically, it was ran into the ground. It saw a lot of use, but anywho, let's hopefully this copy completes, and then we'll get it installed and get it ready to go. Yeah, I've never seen a monitor fail like this before. Perfect up here, terrible down here. But that is, let me fix that. Yeah, that's bad. I mean, that's gotta be the LM1203 that failed, which is that little chip down in there on the neck board. You can barely see it. Crap. So I have it turned all the way down, and if I bring the red up, you can see the red is still very noisy. And I can bring all the other colors up. Blue kind of comes in a little bit after the fact, and then green doesn't really come in. The green's up here, and then it's like it loses its gain as it draws the screen. It doesn't make sense. None of it makes sense. Oh man, that is terrible. No sound either. Huh. Probably a bad driver. Let's see. God, that is awful. Aztec, huh? Well, I'll have to see if that's the right one. Well, the good news is OPL works. So, it's just the wave that's not working. So the sound card's working, but there's something wrong with the wave table stuff. I don't know. Maybe there's a configuration or something. I don't know. I don't want to get carried away too much on that. I need to figure out what's going on with this monitor because it has gotten really bad since it's been on. Because I can't... this is not even usable. Look at that. Yeah, this is really, really bad. Yeah, the longer it's been on, the worse it's getting. So I'm starting to suspect there's a problem with the neck board. So I gotta get this back apart. This sucks. This sucks, but I gotta get it back apart. It is what it is. Yeah, it's great. One thing I will notice, I'm getting ready to take this apart again. So this one's warm, this one's warm, this one's ice cold. So Q902, which is the green driver, is ice cold. So I'm going to have to start checking resistors in here, I think, because that should not be ice cold. These two, this one's cooler, this is the warmest. That one's cooler, and that one's ice cold. So, yeah, that's not good. Alright, I got it all, connected right now so I can look at my voltages. So this is supposed to be a white screen, and notice that we've got the exact same symptom we've had in the very beginning. We're back to what we were originally. So one thing I want to do is, now that I'm getting frustrated, I'm going to go ahead and probe the unit with my voltmeter, which is what I should have done to begin with. But anywho, here's what we're going to do. Let's take a look at our transistor output collectors here. So this is the collector, 85 volts. We got this collector here, 49 volts. That's not right. And it's supposed to be even. And then we have this one right here. Let's see. Yeah, 69. All right. Now, let's look at the 1203. So I got this sheet up. This is the red video out right here. Check you. 2.6 volts. Green video out is right there. Nope. There you go. And then blue video out. So blue is 4.5 volts. I think that's blue. Yeah, blue is 4.5. Green is 0.6. And then red, 2.6. So red is half the blue. And what do we have on the picture? Is mostly red with a little bit of blue at the top, and then it dies off. So that pretty much confirms my suspicions that we have a problem with the 1203. Let's take a look at the VCC at the 1203 and make sure we're still good there. Yep, 11.8 volts, so 12 volt there. And then our VCC2, which is the drive transistors, is 23. So 28, 27, 26, 29, 24, 23, which is right here. Yep, it's the same. So our problem appears to be the 1203. So at least that's what I'm going to suspect anyways. I did check all the diodes and resistors and transistors on this board statically, and they're all good. So that's the only thing I have left is that 1203. So I went digging through my junk stash. I have a parts board for an Apple Multiple Scan 15. Now, I recently, well, it wasn't recent, I did a video on one that had a flyback issue, and I swapped the boards. That's working, but then the plastic started crumbling, so it's whatever. And that's the problem with these, is the plastic starts crumbling. Anyways, this has been in my parts bin, and I just happened to take a quick look, and guess what we have? We have a 1203 IC from Mitsumi. So I could literally just pull this guy out and see if that fixes our problem. Alright, so I got that chip extracted. Hopefully it's still good. We're going to find out. And I got the old one pulled. So we're going to set you off to the side over here in my bad pile. And then we'll get that soldered in and see what the hell happens. Alright, new chip is soldered in. So let's flip the wintertime. Flip the power on there. And then see what happens. Okay. We have a picture. We do. And it still looks a little normal. Oh, wow. It's actually normal. Oh, my Lord. Alright, well, that's a good thing. It's not being washed out or anything. Let's see. Oh, yeah, that is so much better. Red, green, blue. Yeah, yeah, look at that. Much, 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 much better. So that's what it was. That stupid little 1204 or 1203 or whatever it was bad. This guy right here. It was bad. Sure enough. So the Apple Multiple Scan 15 saves the day. Alright, so I spent the last few minutes adjusting the biases and drives. And yeah, now we have linearity. We don't have any linearity issues anymore. So everything is good now. Yeah, we're golden. There's no more problems. That looks so much better now. Alright, so now I feel confident enough I can put this thing back together again and again and again and again. But hey. Oh yeah, that looks so much better. None of that streaking or anything going on there. Yeah, that's it. That's it. We're good now. Well, now we have sound. That just came out of the blue, but... Oh, that looks so much better. So much better. There you go. That'll do it. Oh, yes. What every growing computer needs is a fresh copy of Internet Explorer. Because why not? Now I'm just killing time because this is hard drive is just going to be whatever. Anyways, you know what? Let's do full installation. Actually, no. Explorer, Outlook Express, Multimedia. Let's see. This one comes Net Meeting, Front Page, Net Show, Web Publishing. You know what? Let's just do a full-blown installation because we have the space. Close that because it doesn't need to be open. But yes, it's working. I love it. All right, we are now at that point of the video again. So let's run some benchmarks, shall we? So we're going to go ahead and start. Well, we're going to do a faster benchmark because it's a faster computer. Let's see what this calculates out to be, shall we? Sorry for the flicker. It's not exactly, you know, I don't know if I can get this thing to lock properly. I think this is as close as it's going to get. Yeah, that's as close as it's going to get. Anyways, I don't know how long this thing takes to run, but it's going forever and ever and ever. I think it just runs forever. Anyways, let's see. 3D benchmark. Let's do the highest option, 640 by 480, and see what that does. Oh boy. That is not fast at all. No, it is not fast at all. I wonder if I can escape that. Nope. I gotta let it run its course. Stand by a moment. Does Control C work? I don't know. It does. It actually does. Alright. So, let's see. Now, everyone's favorite. Let's do Doom at max detail. And see how it runs. This is a 486 DX4 at 75 megahertz that's in here. Yeah, that's not exactly playable. But that's also about what I would expect for this CPU without any L2 cache or anything along those lines. So we're not doing too bad, actually. But I tell you what, the picture reproduction is a whole lot better than what we had before. Because what we had before was a really messed up color situation. I ended up putting an Ethernet card in here so I can get all of these files over to this machine, since there's no easy way to do it other than burning CDs, and I was not going to play the CD burning game, because that drive is being picky with CDRs. And they kind of were anyways, but that drive was probably used a whole lot. So it's pretty weak. Now, the audio does not work in DOS, and even inside Windows, the audio doesn't work. It has to be configured properly, and I do not want to go through that. Can't be bothered with it. So, we've got 22.4 frames per second. That's about what I expected. So, Quake is going to run really slow. I mean, for entertainment purposes, we can just go ahead and run it. It's going to be really, really, really slow. Because I think Quake requires a Pentium 1 or better to run. Yeah, this is not playable. So, get out of that. And it's a very dark game. Alright, so Quake, let's see, Landmark. Yeah, that software is a waste of time when it comes to machines this new. So, the one that everybody I know that I see all the time is this one right here, Speedsys. Alright, let's go with that and see what we get here with this one. It's going to calculate everything out in the moment. Let's see if it correctly identifies everything. Oh, let's see, it does. It shows a Mac Store hard drive, because yes, we're running cursed here. Matchetta CD-ROM 572. It works. Not great, but it looks like we have the year 2000 bug in that BIOS. Not surprised. Now, the hard drive test in this one is not going to be the greatest, because this is an old enough BIOS that it has the drive limitations, so I had to use overlay software to see the whole capacity. And the thing about overlay software is it's resonant in memory, and it has to trap all of the BIOS calls, which eats up more CPU cycles, so you're not going to get as good of a performance as, say, you had a native BIOS without any of the bugs. And, you know, as far as limitations are concerned. So we're not going to do that great in performance. An XT to IDE modded BIOS would be better for this, especially using the onboard IDE controller. You would just take it over, but it is what it is. And that might be something to play with down the road. But as far as this machine's concerned, it is working properly, and I'm happy with it. I think we're good enough to go back to its original owner. So I'm going to let this stuff run and see where we go from here. Yeah, as I expected, with only 16K of L1 cache, we're kind of rolling off pretty heavily at the 16 mark. So that makes sense. Our processor is performing a little better than the 50, but obviously not as much as the P133, of course. So, and the thing is this graph does not have a DX4 mark on it, which is kind of surprising. But, anywho. Alright. So now we're ready. We've got all of that done. Now we're ready to do the hard drive test. Very interesting noise. Even with the overlay software, we're not doing too bad. It's not great, not as good as a 13 gig drive should read, but it's not doing bad for what it is. So the overlay software that's trapping the BIOS calls does have a little bit of an impact on it, but not much. But that's just the downside of using drive overlay software to get around BIOS limitations. It fixed the problem at the time, but it comes at a cost, and that cost is the impact to system performance, which for a 486 kind of matters. 46 Pentium era stuff like 286, 386 probably doesn't matter a whole lot with how slow it is. But with 486, especially high performance 486s and newer, you're gonna notice speed impacts when you're using stuff like that. Hopefully this graph down here populates here soon. Alright, so there we go, 507.10, which is just under our typical 14 gigabyte performance. Now granted, that's a different drive, but we should be pretty close to that, and we're just under it a tiny bit, which makes sense because we have the overhead of the drive overlay software, but we're actually not doing too bad. So I'm going to let this run out. This is going to take a very, very, very long time, and we'll come back to it after it is done. And there we go. All of the tests are done. Hard drive tests are about where I expected it to be. And then we are done. So everything's all good. Let's see. Let's get the memory information, because why not? Yeah, cache obviously is faster than main memory. We're running about not great, but it's not EDO or anything. It's just traditional fast page memory. So we're good there. And that is it, I think, as far as what we're doing here. So I'm just going to reboot the machine and get it back into Windows. So yeah, that's it for benchmarks. And of course we had to run Doom just to see it run Doom, because why not? Man, that monitor works so much better. There's the on-track drive overlay software that we have to use. And it supports CD-ROM boot, even though it probably doesn't have the driver built in for that drive. But anyways, yeah, I did not shut it down correctly because, whatever. It's Windows. It's Windows 95 on top of that. There's probably issues in the file system. Who knows? But you can definitely tell it's a bit slow because of the drive overlay software that's running in the background. Anywho, we're going to let this guy run so we can get this thing fully started up and make sure it starts all the way up, which it should start all the way up, because, Windows should sometimes start all the way up, because start all the way up. Yeah, now I'm rambling. And there we go. Now we're starting up Windows, and I'm trying to get this camera to sync, but it's not cooperating. I'm sure there's a way to do it, but there's like 50 billion different functions on this camera. So, and the whole point of using this camera is for syncing to a CRT, but whatever is what it is. And it decided not to play the sound. Huh. Okay, well, it had sound before, but it doesn't now, and it did before. I don't know. This thing is so weird sometimes. It'll just do that. It needs the right... Let's shut this thing down. We'll try again. Alright, so now we're booting up Windows 95. So hopefully everything still works. It should. Nothing has changed. Although the sound hardware can be temperamental on this machine. I don't know why. We'll see. Nope. No sound. And I bet anything that even though I don't have any sound in the wave table, hardware, whatever you want to call it, I bet as soon as I start up the MIDI format, the MIDI player, which uses the OPL chip, as soon as I do the MIDI chip, I guarantee it'll work. That's what I thought. Yeah, MIDI hardware works fine, but the wavetable hardware does not. It'll do that. So let me cut the power completely off. Turn it back on. And see if it comes back alive. I don't know why it does that. I gotta figure that out. Now with a fresh power cycle, let's see what happens. Hopefully the sound comes back. MIDI worked, but Wave did not, so I don't know. We'll see. Is it gonna work this time? No. No, I don't know what. The sound hardware just quit. Oh, I love this thing. Alright, well, we got to figure out what's going on with that. And I'm pretty sure Packard Bell was notorious for that. You got to have special tools to fix that. Alright, I downloaded the DOS sound drivers. Let's see, there's this AZ Cal here. See what it does. Nothing. Let's see if that solves our problem. Hopefully that solves our issue. Because I don't even know. Let's see if Windows will start up and if that solves our problem. These here want to make floppy disks, and I'm not making floppy disks. I wish it would just kind of extract without the need of making floppies. Wow. Yeah, it seems like I had to run that program. Alright, well, I'll have to keep a mental note of that. But anywho, this is done now. I can go ahead and start wrapping this thing up and getting it put back together. Let's try running Doom plainly without the benchmarks. See if we get sound. Oh yeah, we do. That's awesome. That OPL chip, man. And there we go. We're all back together again. Everything's all screwed together. And there are all of our casualties, including that 1203 that put me through the ringer. But hey, you know what? You live and learn. So anyways, it's all good to go. It's ready to go back to its original owner. And hopefully we got some good video out of that. And the CRT is really strong in that thing too. So that's actually good. Anyways, if you enjoyed this video, don't forget to hit the like and subscribe and all that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching.